Hello, my dear students. Welcome back to my class. In the series of learning programming in C, in the previous video, we have already discussed about malloc function, calloc function, and realloc. In today's video, let us understand about free function. So those who are new to my channel, please subscribe to my channel and click on the bell icon so that you can get the notification of all the new videos. Watch the video till the end. Do not skip the video. And if you like the video, please click on the like button and share the video to all your friends. Free function in C. So what is this free function? So free function is used to deallocate the dynamically allocated memory. So that what we allocate using calloc, malloc or realloc. So those memory will be deallocated using free function. And it is very compulsory and mandatory to deallocate the memory using this free function, because memory allocation, that what we do using calloc, malloc and realloc, has to be deallocated using free only. And it's a good practice of a programmer so that we can use the memory effectively. Deallocated memory. So once the memory is deallocated, it is sent back to the heap memory. So you will have a collection of memory. So we all know when we deal with the program, we have some static frame and then the heap frame. Or we can say the stack frame and the heap frame. In the stack frame, all the static memory allocated data will be stored. That is in the stack frame. So you will have two frames. All these things I have told in the previous programs and all. So in the stack frame, we have static memory allocation data. Whereas in the heap frame, we have dynamic memory allocation data. The pointer that what we create, that will be in static only. But the location that what it is going to point to, that will be in the heap frame. So we have stack frame and heap frame. Stack frame usually deals with static allocation and the heap frame deals with the dynamic allocation. So memory in the heap, that what we have. See, once we deallocate using free, that memory will be to the heap memory. Once again, it will be sent back to the heap memory. And that sent back memory, that memory that what we have in the heap, we can reuse it. And once the memory is free, we cannot access the data also. So once we use the free function and deallocate the memory, we cannot go and access the data. Dereferencing through pointer should not be done. Free function can only deallocate the memory, but data cannot be erased. Memory will be deallocated, it will be back to the heap memory. But the pointer will be still pointing to that location. It will have that address. But with that address, we cannot dereference. Dereferencing should not be done. But data will be there itself. And the next calloc or malloc, which will allocate the memory, will get the memory from that heap itself. And the data will be there and we can overwrite the data on it. This is what happens. So for example, I create the pointer. I just say int asterisk ptr. I say ptr equal to typecast to integer. Then I say malloc. Say 3 values I need to store of size of, say, int. So now what happens? Malloc function is allocating to store 3 elements of size of integer. So for example, it is 2 bytes. 3 into 2. So totally I need to allocate 6 bytes of memory in the heap. Okay. And I need to typecast that to integer and the address of that should be held in pointer. So int asterisk ptr means it is in the stack frame. So here we have the pointer variable. Say some address we have got, some memory is allocated through malloc. Say the base address is 1000. So that address will be held here. So pointer will be pointing to this location. So we will perform some operation as usual. We all know in the previous programs and all we have dealt how to store the values through pointers, all those things. Just assume we have allocated some data, or we have inserted some data. Say let me say the values that what I have here, it is 10, 20 and 30. Okay. Now through pointer we will access it. After performing all the operations, what we'll do, we'll simply say free that PTR. Syntax is very simple. It's a keyword free, it's a function name followed with this pointer PTR. So as soon as the compiler, so when the machine encounters this free function, it has to release that memory pointed to by this PTR. PTR is pointing to the location 1000. So I need to free this memory, means this memory will be freed. Again it will be back to the heap. So memory is free. Now pointer is pointing to that location, but this is not available now. It is deallocated. So it is deallocated, so that particular object is not available. That memory, that complete portion is not available. It is back to the heap collection. So you have the heap collection, it is back to the heap collection, but the data remains as it is. Later, if I just say I want to reference with this, after you say free pointer, I say asterisk PTR plus, so I want to access the second data, say it is index 0, 1, 2. So I say PTR plus 1. So if I start to dereference with this, then the program starts to behave differently. So here an unusual behavior, an undefined behavior occurs. Segment error or some other error, your program may crash. So all these happens when you dereference it. Dereferencing means what? Dereferencing in the sense referring to the location and trying to access the data. So the point says we cannot access the data. After you reuse, free the memory, it will be back to heap. Of course we can reuse it. So after free, once again you can say the malloc function and allocate few more data. Say some more data, say I want to store some 5 elements. So again the same memory can be used. It can be reused, but the new data that what we try to store will be overwritten on this. And if I try to dereference it, if I just try to access it, you cannot access. You may get some junk values. After you free the pointer, the memory is released. It is back to the heap memory, the heap of memory. It is back to that heap frame. I can reuse that for next allocation, but I cannot dereference it. So after performing all my operations, I have stored some data, then I say free, then the memory will be released and it will be back to the heap memory, and that memory can be reused for next allocation. Data will be there itself. After free, if you try to say asterisk PTR plus some location, then you cannot dereference. The program may give some wrong output, or it may behave in an undefined way. So we should not dereference it, and we cannot erase the data also. So this is what with the free. So when I say free, what happens? We say the memory is vanished. So it is not vanished actually. The memory will be released. So in the dynamic memory allocation, the user has to manually use this function to deallocate the memory. So once the memory is released, it is back to the heap location. Maybe this pointer will be pointing, it will have that address, but this location will not be available. So dereferencing that unavailable memory is not good. Dereferencing that unavailable memory, the memory which is not available for us, it is released actually. So the memory which is not unavailable, we cannot dereference. And if at all, if you dereference also, you get some junk values. You get some junk values. So it is not a good practice to dereference the data from the memory which is released. Of course, you can reuse it. After free, you can once again allocate the memory with calloc, malloc or realloc. Then the same memory can be used. And if you try to store new data, it will be overwritten. So this is what happens with free. So let us understand this complete process with an example program. Here we go with the complete program to understand this free function. So the same program we are using, same alloc function. We are allocating the memory. So we have a pointer here, ptr. So ptr is going to get the address of the base address. So as you should enter the values, then we will say the entered values are, we are going to print it, and at the last we will say free. So let us check this program first. So the same malloc program that what we have understood in the previous video. If you have any doubts with this, you can please go and check the playlist. Save the program and run the program. See, enter the number of values. I say 3. Enter the values, say 56, 78, 89. I'm going to get the values. Now what I'll do, I'll just comment this free, and after accessing the values, I'll free the pointer. I'll say free ptr. So before I print the values, I'm going to free the pointer. Now let us check what happens. Save this, run the program. So enter the values, let me say 3. Number of values is 3. Now values I am giving. Now as I am using the free function, after accepting the values, see, I am going to get junk values. See, the last value somehow I have got it. But sometimes you get complete junk values. See, 676336 or something, some junk values I have got. So this is what happens when we free the memory. So when the memory is released, it will go back to the heap. And once again, after this free, if I allocate using malloc or calloc, the memory will be allocated. And I may use the same memory. Data remains the same, but the new data that what I give will be overwritten on that. Free will not erase the data. It will only release the memory. And the pointer will still have that address. But dereferencing that address is not good practice as programmer. And if we dereference, what happens? You get the junk value. This is what we have. This is what the output we have got. So we started dereferencing after releasing the point memory. See, when we started dereferencing here, then I get the junk values. See, dynamic memory allocation, we have to use free function to deallocate the memory. Whereas in static memory allocation, the compiler will automatically release the memory when we come out of the program, when we exit the program, when the program ends. But in dynamic, we have to deallocate using free function. And this is how the free function is going to work. So that's all for today's video. See you in the next video. Till then, take care. Bye-bye.